Okay, so there's something called orthogonal. Okay, so if I give two vectors, you'll say that those two vectors are orthogonal to each other, or orthonormal to each other. What does it mean? Their dot product is 0, or the inner product is 0. Okay, then we call that as a orthogonal. Okay, so now let's say mm, let's say between 0 to 1, mm, ah, between -1 to 1, let's say. Okay, that's the interval. I want you to check whether the function f of x is equal to just constant 1. Okay, and then g of x is equal to x. Okay, so tell me, are they orthogonal to each other? So we know that inner product is f of x g of x dx. Is it coming 0? Okay, so now say between 0 to 1. So it's 1 by 2, which is not 0. Okay, so when we say something as a magnitude or something as a whether they are orthogonal to each other or not depends on the interval. Okay, so it's not say if I take two function, and it's not that it always be 0. It depends on in which interval I'm doing that inner product. Okay, and one more thing, the way you can think the inner product is graphically. Okay, see, graphically, you can think a function as a vector in the following manner. Let's say you have a vector, first component, second component, third, fourth, like that. Okay, so what you could do is say label the first component, second component, third component, fourth component, like this, and the value of the first component you could put it here. The value of the second component you could put it here, put it here, put it here, something like this. Okay, so in this way, you can graphically represent a vector even if the vector is some large dimension. Okay, and also is that part? Okay. Now the thing is, say the vector is a very large vector. It has an infinite dimension, and then what you do, you kind of squeeze all those points. Okay, put together, what will happen, kind of the gap between the 2 points will come, I mean will vanish, and those 2 points will come together. Let's say when it comes together it forms a continuous curve, then that continuous curve is what, a vector. Okay, so in that manner you can think a function as a vector. Okay, now let's say what is the inner product. Okay, so the dot product, what you will do, first element into first element of this. Okay, say for example this is first vector, and let's say the second vector is like this. Okay, what you will do, uh, first element into first element plus second element into second element plus third into third plus fourth into fourth, like that. And here what you are doing, okay, so it's like say you have a function, um, you have a function, okay, the interval, and there is another function, let's say that interval. Okay, now what you are doing, f of x into g of x, which is basically you are multiplying this value into this value, and then the integration is nothing but the summation, right? And then this value into this value, this value into this value, like that you are doing basically, right? So from that understanding you could see why it could be a inner product. Okay, fine. So why are we bothering about this inner product and the orthogonality is it has some applications, mm, which I will describe in using this vector. So alpha into, let's say, 1 0 plus beta into 1 1, which is equal to, uh, let's say it could capture any vector, right? Let's say it's AB. Okay, A could take any real number and B could take any other real number. Okay, now the question is, what is what is alpha and what is beta? And first of all, we know that this vector, let's say that vector is v1, and this vector, let's say that vector is u, and this vector is v, and u and v are what to say, linearly independent, right? And those two vector can span the entire R2 space, right? So which means any such vector I can represent uniquely a linear combination of u and v. In that case, there will be a single solution for alpha and beta, right? So what is that solution?